Hey, all, Brad here with another video. Had a friend of mine, John, send in an Inferno MPU. He takes this game. He has got a beautiful original Williams Inferno. Takes it out to CAX every year. Uh, Everybody really enjoys playing it. Most people, almost never have the opportunity to play such a rare game. He brought it this past year. Apparently, after the first day, it quit working. There's another guy, Kevin, there. They worked on it. They were messaging me. I was trying to help as much as I could, remotely. Um, they ended up not being able to fix it there. When they came back, they tried some more stuff and was still stumped. So they had a spare Joust 2 board set that they converted the MPU over and got the game up and running again. But we're still struggling to get the board going. So uh, we agreed he'd send the MPU over to me because they validated that the video board was good. And I got it yesterday, and I've got a bit of a backlog, but I really was curious to find out what was up with it. So I built a configuration for the FPGA cat box that Fred Cawthorn has built. This is an amazing tool. I've showed it a couple other times, but uh, just kind of rudimentary. I'm able to test all of the 416D RAM on the board. I can test the CMOS RAM. I haven't mapped out the SRAM, but I can test those. What I was really interested in is testing all the ROMs. It actually goes out and reads the checksums on them and does a compare with the files you've stored. So let me switch over to that cam real quick. I'll show you the setup actually maybe first. Let me switch over to the bench cam here with the so just show you kind of the setup here, what I did. So this is the MPU. Spoiler alert, it's actually all repaired now. This is the cat box, the FPGA cat box, and it's got a 50-pin ribbon cable that comes off over here and a header that plugs into where the CPU, the 6809E in this case, goes. He's got a Z8 adapter. You can do a 680208 and some other, other stuff. And then I've got a ground just attached over here to J4 here. The pin 10 is ground, I know that. And you can see all the ROMs are here. He does have a NVRAM module in, so that hence no batteries on the board. This thing has never seen any corrosion either. Um, Someone had put some new electrolytic filter caps here. They've got a new 22 microfarad for the soft start. That's good. I actually went in and added a 470 microfarad cap here on the audio amplifier output and a 100 microfarad here, both Nichicon. Did a few other little cleanups on it, but other than the parts I changed, which I'll get to, those were the only additional components. So let me switch over, get back down here. I'm trying to do this without having to edit it after recording, so bear with me. So now you can see on the screen here, I've got this is the FPGA catbox tool. So I've created a configuration for it. This is where I map all the ROMs and the RAMs. These have a lot of bank switching on this board, these Gen 2 boards compared to the original Williams. So um, there's some great tools in here. This data trace is fantastic for figuring out what the addresses are on the address range on each type of component. So you can connect your data line to the chip enable on any EEPROM, RAM, whatever, and then you run a full trace where it sweeps the whole address range, and you can see where that enable becomes active, and it'll give you the address range. So it's really great for that kind of stuff. But let me power the board up real quick here. Okay, and if I go over to RAM, so these are the three banks of 4016. There's 24 of them here. And then this last section here is for the CMOS RAM, which I've actually tested. We do have a way to back up what's in the CMOS and restore it. But I tested it initially, and it'll just wipe whatever's in there, just writes random data here. You can see. So I'm going to actually disable that for now, but let me run the test. And it'll sequence through because the top three are enabled. So it'll run through all three banks, and we've got green, all okay. So it tests all the RAM on all the banks. And I will be adding the SRAM to this test, but and then I have disabled the CMOS just so I don't wipe it out right now. And then for the ROM, this is pretty slick. I can do start ROM test. and it just went through all of the ROMs on the MPU, read the code in them, and calculated checksums and compared them with stored checksums, and so they all passed. So I did this initially on the board and got the same results, and the board was basically hung during when it was trying to do the ROM test. So that made me believe that the hardware was working right, but something was preventing the actual game code from executing. So first thing I did is I started looking at the inputs because anywhere where this board touches the outside world, they tend to buffer the data through buffers, inverting buffers in this case. So let me switch over to a schematic here. So this is the connector J4 on the board. Comes from the coin box, it says. So what you have in here on J4, pin 1 is the memory protect. So that basically protects the upper range of the CMOS RAM unless the coin door is open. That prevents somebody from setting free play or something without having a key to open the door. Pin 2 is just a key, so you can't plug in the wrong thing. 3 is from the slam switch, kind of a carryover from the pinball world. They're still on the coin door. 4, 5, and 6 are the 3 coin slots, right, center, and left. And then the last 3 here are from the diagnostic switches. So you have the high score reset, advance, and auto up. And I have run into on the other Gen 1 boards where if one of these was basically held down due to a chip failure or a pull-up resistor or something like that, that the game would not go into, would not boot. So back to the schematic here. So I started checking. These are 4049 inverters here. And basically, you have all these inputs coming into this gate. And whatever comes in on the output is inverting, so it will be the opposite. So if you're high here, it'll be low. If you're low here, it'll be high. So I just started checking these with the scope probe and found that pin 9 and 10, this is the match pair here, were both high. There's no situation where you would have both of them matching. They should always be the opposite of each other. So that indicated to me that most likely that chip was bad. I took it on the bench, pulled it, tested it in a dedicated chip tester, and sure enough, it's bad. So I swapped out the 4049. Before I did that, I went back and looked. So this was on pin 8 here, and lo and behold, pin 8 is the advance button. So basically, it would be like trying to boot the game while somebody's holding the advance button down is what was happening. So as soon as I changed to the 4049, put it on the bench, she booted up no problem. I did corrupt the CMOS, so I had to do a power cycle on it to get it to reload that NVRAM. But once it came back, then I started testing everything else, and so I can do that right now. I showed you the FPGA cap box. Let me power off. I'll put the CPU back in. We'll boot up the game, and I'll show you how I test these guys here. Let me switch over to, we'll boot up here. Whoops. Helps if I put the CPU back in. I took the cap box out, but there we go. This is the normal memory test, rug pattern. After this, it'll go into testing the ROMs. Here we go. All systems go. And right into a track mode. So let's see here. Let me try to hook this guy up so maybe we can get some audio too. Not sure. I haven't really tested this. Oh, yeah. So I'll hit play here. We'll play a little bit. Ooh, got me. So you can see the gameplay's fine. Let me drop into diagnostics, and again, it'll run another RAM test. No RAM errors. ROMs are good. No CMOS RAM errors, which is NB in this case. So it goes through 8 tests. So here we are on the switch test, and this is what I want to kind of go over. So let me switch over to the gameplay with the bench camera. Maybe I can set this up so you can see what I'm doing here. Let me try to zoom in a bit, and maybe I'll lower it down here so you can see the where the headers are. Oop, that's a bit much. Sorry here, this is probably gonna, that's better. So what we've got here is the, this is J4. This is the header for the coin door stuff, and then these other two over here are J5 and J6, and these are from the controls, from the joysticks and the buttons. So what I'm going to do is connect just a jumper over. I know that pin 10 here is ground, so I'm going to connect to pin 10, and then I'm going to go through and read these off, and we'll test each one of them. So, except advanced, because I don't want to leave this screen, which I know works. So, pin 1 is the memory protect, which there's really nothing on this screen to see. 3 is 2 is key, 3 is a slam switch. I'm going to ground that one. You can see that triggering. And then 4 is a right coin. 5 is center coin. 6 is left coin. 7 is the high score reset. 8 is the advance, which we're going to skip. 9 is the auto up. So those are all working. And then we'll jump over. Let me scroll here to J5. So J5, you can see I've got the little jumper here and the other inch is connected to ground. I'm going to start here at pin 1. So that's player 2 start, then player 1 start, and then trigger for player 2 is on 3, and then trigger for player 1 is on 4, and then aim down left player 2 on 5, and then we got a key on 6, and then 7 is aim down right player 2, and then we've got aim up and left, up and right. Then ground is on 10, so that's why nothing happened there. And then 11 is down and left, player 1. And then we've got down and right, player 1. And then I'm going to jump over to J6, pin 1. And let me scroll the screen so I know what to expect here. Should be up left, P1. And then we've got up right, player 1. Run down and left, run down right, up right, we've got down left. That's me not making good connection over here. Down to the right, up left. That's ground, and then a key. And then this was interesting, and Kevin mentioned that he thought one of the pull-ups was bad. There's a pull-up resistor here. So this is the last input, which is run upright for player 1, which apparently was not working. So that one I looked into, and I found a 74157, which is like a muxer here that allows for all of these inputs to go through a few on the PIA. So that IC was bad. I ended up snipping it just to make sure because the resistor was, with nothing connected, it should be sitting at 4.K to +5, and it had a couple hundred ohms on it. So snipped the pin going to the IC, and it went right to 4.7. So I swapped it out and brought it back to life. So you can see all the inputs are good now. I've tested every single one. And I'll go ahead and plug in the connector again. And we can switch back to exit this. Just finished going through the diagnostics here. There's the advance. Then it gives you the grid lines to set your convergence, red, green, blue, color bars, bookkeeping data, and then game adjustments, and then back to a track mode. We'll wait for the little Bleeding Inferno logo to come up here. This is the high score table. There she goes. So this board's wrapped up. I can switch over real quick, just show you the parts. That kind of audio pulsing you heard is from the capture device. It's not the greatest. So here's the 470 microfarad capacitor for the audio and the 100 mic. I changed those out. And then here we have the 4049 inverting 4000 series buffer, and then the 74 LS157 that was bad. So really that's all the parts it needed. And I'm going to get this boxed up coming back to them. Thanks for watching.